Hi, in this video, we are going to talk about mesh analysis. So mesh analysis is a method to solve an electrical circuit, right? So the other method is nodal analysis, which we will discuss in another video. And so in mesh analysis, you basically aim to find out the mesh currents or currents in your electrical circuit. So just keep in mind that mesh analysis is slightly different from a loop analysis, and that we will discuss later in the video. So first of all, you need to identify meshes. So remember that to identify a mesh, you need to start from a node and that you have to end at the same node. And the rule here is that you cannot repeat a node while tracing a mesh, and that your selected mesh should not have smaller loops in it. So keep those two rules in your mind. So for mesh analysis, I've got this circuit here, and I've got 3 resistors, a voltage source, and a current source. First of all, I'm going to identify meshes. So I've got one mesh over here, and this is my other mesh. The second step is to mark my mesh currents. So remember, you're actually aiming to find currents through mesh analysis. So first of all, you need to mark your mesh currents. So my first mesh would be this one, and it would have a current I1. And I'm going to mark them with a capital I so that I know that this is a mesh current. And then the second mesh would have a current I2. Now, at this point, notice that I marked these two currents in an clockwise direction. So you can choose either clockwise or anti-clockwise, but you need to be consistent with it. So this would be my technique. So I would be marking my currents in clockwise direction, and I would be marking them with capital letters. So the second step, so you've identified your meshes, you've marked your mesh currents. The second step is simply to apply KVL or Kirchhoff's voltage law in each of these loops. If you don't know what Kirchhoff's voltage law is or how to apply it, you can find the link in the description below and learn how to apply Kirchhoff's voltage law. So for my loop 1, this is going to be my loop 1. I'm going to write the KVL equation, and I'm going to start with the source voltage. So this is a 5-volt battery, and you can see that the current is moving from the negative potential to the positive potential. I'm going to put a plus sign with it. So this is a 5-volt battery. And then the 7 ohm resistor. The resistor would have current flowing from this direction to this direction. And as we discussed this in our previous videos, that a resistor basically gives you a voltage drop. But over here, you're going to mark positive and negative for each resistor. This will help you with solving the circuit. So I'm going to mark positive sign from where the current is entering the resistor and negative sign from where it's leaving it. So it means that there is a voltage drop. And so I can write 7I1 over here with a negative sign, and 7I1 is basically using Ohm's law, which is V is equals to IR. This is actually the voltage across the 7 ohm resistor, which I've written directly over here using the Ohm's law. So 7 ohms into I1, which is the mesh current. Then comes the 10 ohm resistor, and for this I need to draw it separately. So for 10 ohm resistor, you can see that both the currents I1 and I2 are basically flowing through the 10 ohm resistor. So if you look back at the original circuit, you will see that a current that must have left the 5-volt battery entered the 7 ohm resistor, and then it hit this node over here and then divided into 2 parts. Right, so the 10 ohm resistor has a current that is flowing downwards. Now, keep the currents that are in the branches, that is the currents in the 7 ohm, 3 ohm, and 10 ohm resistors separate from the mesh currents, so you don't get confused with them. So I'm going to mark the current that entered this branch over here as a small I, right? And now I can find out the current by using the mesh currents available here. So small I equals to the sum of I1 and I2. And I can see that I1 is in the same direction as small I, and I2 is in the opposite direction. So I'm going to give a negative sign to I2. So basically the small I, the current through the 10 ohm resistor, is the difference between I1 and I2. Now I'm going to go back to my Kvl equation, and I was writing the voltage across 10 ohm resistor. That would be 10 multiplied by whatever current is flowing through it, and that we found out as I1 minus I2. And I'm going to give a negative sign to this voltage because it's a voltage drop, because it's a resistor. And so I've got no other component over here that I can write the voltage of. I'm going to put it equal to 0. Now we can easily solve this. So it's 5 minus 7I1 minus 10I1 plus 10I2 equals 0, and you solve it down to, and it becomes 17I1 minus 10I2 equals 5. This is one equation. Next, we're going to move on to the next equation. So the flow would be that I identified the meshes, and then I marked my currents, and then I'm just writing the Kvl equations and solving it down to the simplest version, right? So for loop 2, I'm going to repeat this process, and I can see in loop 2 it's very easy. So the current I2, the mesh current I2, is equal to the 20 milliampere source current. And this is one of the benefits of using mesh analysis if you have current sources in the circuit. You can find out the mesh currents directly. So I2 can be written as 20 milliamperes directly, and you can put this value over here in this equation, and you would get 17I1 minus 10 multiplied by 20 milliamperes, and milliamperes would mean that it's divided by 1000. You can solve it down, and it would come out to be I1 is equals to 0.306 amperes, or you can write it in milliamperes. It would be 306 milliamperes, right? So this is the solution to this circuit over here. And we've just found out the mesh currents over here. You can put these values to find out the individual voltages across your resistors if that's what your question is about. Okay, so this is a practice problem for you guys, and you need to find out the mesh currents in this practice problem. Hit the pause button here and then resume the video after you've solved the circuit to see the solution. Okay, so this is a little bit different from the previous circuit. We've got two voltage sources over here, and we've got multiple branches, right? So first of all, we're going to identify the meshes. So I've got one mesh over here, right? So I'm not repeating any nodes. The initial node is my final node, and there are no further loops within my mesh. So I've got one mesh here, and then this one over here, and then this is the third mesh. The second step is to mark my mesh currents. So this one would have a current I1, this one would have a current I2, and this one would have current I3. All three of them are capital, and all three of them are in clockwise direction. The third step is to apply Kvl equation. So the first loop has a voltage source. I'm going to write 10 over here because the current is entering from the low potential and going to the positive potential, and so that's a voltage rise. So I've got 10 minus, now I'm using the Ohm's law to write the voltage across the resistors. The 2 ohm resistor would have 2I1, which is the mesh current, and it would have a negative sign. And I'm also going to mark the polarity over here, positive and negative. And I'm going to do the same thing with the 5 ohm resistor. And for the 5 ohm resistor, I'm going to draw it over here, and I'm going to find out the current that flows through this resistor. So looking back at the original diagram, I can see that a source current would have left the 10 volt battery. It entered the 2 ohm resistor, and then it would divide into two parts. One would be through 4 ohm resistor, and the other one would be from 5 ohm resistor. So the 5 ohm resistor is receiving a current that is going downwards. So that I'm going to mark that as an I. That I would be equal to the sum of these two currents. And again, the same concept applies, that since capital I1 is in the direction of I, it would have a positive sign, and capital I2 would have a negative sign. So this is the current through my 5 ohm resistor. Now going back to my KVL equation, I can complete it and write down minus 5 multiplied by I1 minus 2 equals 0. Now I can simplify this, solving it to the simplest form possible. I get 7I1 minus 5I2 equals 10. And this would be my equation A. For the second loop, we're going to repeat the entire process. The first component that I have to write the voltage of for my KVL equation is the 5 ohm resistor. And in this case, if you see that I2 is entering the terminal that I marked with a negative and then leaving through a positive. So this is a voltage rise. And I'm going to write a positive voltage for 5 ohm resistor for this loop. And so 5 multiplied by the current flowing through it. The current flowing through it would be I1 minus I2. We won't change this over here and we don't need to calculate it again. Then the voltage across 4 ohm, that would be 4I2 because I2 is the only current passing through 4 ohm resistor, and I'm going to mark it as a negative, and I'm also going to give it a plus and minus sign. And I'm going to go over to 10 ohm resistor, and it has 2 currents passing through it, so I'm going to write the equation for the current over here. I'm going to draw it again. So 10 ohm resistor is getting a current in the downward direction if you see the original circuit. So the current from the 4 ohm resistor must have hit this node here and then divided into 2 parts. And then the 10 ohm resistor would have a current in the downward direction. And also has I2 and I3 flowing through it. I2 is in the direction of I dash, and I3 is in the opposite direction. So I dash should be equal to I2 minus I3. Going back to my KVL equation over here, I'm going to put these values here, and then I'm going to write minus 10 multiplied by the current through 10 ohm resistor, that was I2 minus I3. And then I'm just going to open the brackets, add and subtract where I can, and I get 5I1 minus 19I2 plus 10I3 equals 0. And I'm going to mark this as my equation B. Now for loop 3. So loop 3 has just 2 components in it, 10 ohm resistor and a 5 volt battery. The 10 ohm resistor already has a polarity marked to it, so the current I3 is entering through the negative, exiting through the positive. This would be a voltage increase, and I'm going to write it with a plus sign. So 10 multiplied by the current through it, if that is I2 minus I3. Then the 5 volt battery has the current entering through the positive, exiting through the negative. So the voltage for this source would be a negative. So minus 5 equals 0. So open the brackets up, add and subtract, rearrange your equation, and you will be left with I2 minus I3 equals 0.5. This is my third equation. Now, so you've got 3 equations over here, right? Because you had 3 meshes and you had 3 mesh currents. So you were supposed to find out 3 independent equations. And this is a basic maths law. Since you have 3 variables, that is the 3 mesh currents, you need 3 independent equations that you can solve simultaneously to find out those mesh currents. So I've got my equations A, B, and C. All are in terms of I1, I2, and I3, and I can solve them simultaneously, and I will get I1 equals 1.71 amperes, I2 equals 0.394 amperes, and I3 equals minus 0.106 amperes. And the negative sign obviously means that I've assumed my current direction in the reverse. So I'm just going to reverse the direction here. The magnitude would remain the same. So this was a very, very simplified explanation of mesh analysis. Right, so if you need to find out your mesh currents, if you need to find out currents in general, mesh analysis might be the best option to apply to your circuits. However, there are two scenarios where mesh analysis becomes a little complicated. So those two scenarios are, number one, when your circuit is non-planar, where a non-planar circuit would be the one in which you have wires crossing over each other, like the one over here. So in these situations, you can definitely apply mesh analysis, but it would be very difficult to solve. So you might want to try some different approach to solving these circuits. The second scenario is when you've got a current source in between two meshes. In this situation, again, you can apply the mesh analysis, but it would result in a very complicated solution, and you would have very complicated equations to work with. So a better idea is to go for loop analysis. And in loop analysis, basically what you do is you select one mesh, like over here, and then you select a bigger loop. And I'm calling this bigger one a loop because it has two smaller meshes within it. Your bonus tips for this video are that for a successful mesh analysis, you need to, number one, include all the elements while writing your equations. Number two, when writing an equation, make sure that at least one element in your equation is not shared by another mesh. By following these tips, you will ensure that you end up with the right number of independent equations to solve for your variables. Great, so this is it for today. I hope you found this helpful. If you did, please leave us a thumbs up and share with your friends and family. See you in the next video.